Right, part A, state the probability density function. It's a uniform distribution between 0 and 5. So 0 to 5. So the height of the rectangle is going to be 1/5. R has been used, so I'm going to call that R, and that will be f of R. So that's what it would look like. Let's state that now. F of R is 1/5 if R is between 0 and 5. Should really put a comma in between there. And f of R is 0 for all other R values. That's it for part A. Now for part B, find the expected area of the circle. The area of the circle is a function of the radius. So I'm going to use capital A for the area of the circle, and that is obviously pi times the radius squared. If R is a random variable, then A is also going to be a random variable. R is a uniform random variable, uniformly distributed, so it has an even probability between 0 and 5. So if we drew the graph of R, we get a horizontal line. However, if we drew the graph of A, we wouldn't get a horizontal line, we'd get a curve. So obviously A is not a uniform distribution. So we mustn't go using the formula A plus B over 2. If we're finding E of A, it's not going to be giving us the right answer. Instead, let's think about, we're trying to find the expected area of the circle, so E of A. Just above I've written A is pi r squared, so we're actually finding the expected value of pi r squared. Now this is the same as pi, because pi is a constant, multiplied by the expected value of r squared. Now at a point where I can use the general formula that the expected value of a random variable is the integral of x times f of x dx. So I'm going to use this for r squared. So it's the integral of, I mustn't forget pi. So it's the integral of r squared, we should use lowercase letters for the integral, times f of r. Integrate with respect to r over the whole range, so we're going to go from 0 to 5. Now f of r is a fifth, because r is a uniform distribution. It's a constant, 1/5, so I'm going to bring it out to join the pi. So get pi over 5 times the integral of r squared between limits of 0 and 5. We've done all the hard work now, just need to finish it off. So integrate, put the limits in, and we get 125 pi over 15, which cancels down to 25 pi over 3, because top and bottom have a common factor of 5. So that's the expected area of the circle, 25 pi over 3 units squared. In part C, we're finding the probability that the area of the circle is greater than 25. So that's probability A. Oh, shouldn't have closed the brackets there. A is greater than 25, which is the probability that pi r squared is greater than 25. Let's divide both sides of the inequality by pi. So it's the probability that r squared is greater than 25 over pi. And now let's square root both sides of the inequality. We don't need the negative square root because r is a length, it's positive, so just a positive square root. So we now find the probability r is greater than the positive square root of 25 over pi. we go back to our drawing in part A, we'd find the decimal that is the square root of 25 over pi, and the chance that r is greater than that will be the area to the right. So this rectangle will have a base of length 5, take away root 25 over pi, and the height of the rectangle is 1/5. The question does say to 3 decimal places, so let's put this into the calculator and we get 0.436 correct to 3 decimal places.